So what we have been doing up till now, we have been discussing the reactivity series, the metals, right? And in metals, we said that metals, the reactivity of metals can be distinguished and understood by reacting them with three different three different reactions, by putting them into three different reactions. First one was the most reactive metals were able to react with cold water or water at room temperature. And the ones that are able to react with water, they are considered as one of the most strongest of the metals, and they are at the most top of the reactivity series. Then as we move down, we see that there are some metals that do not react with water that readily, right? They need to be either they need to be either hot, they need to be either red hot or something, or they need to be in a state in which they are at a higher temperature. That is the only time they somehow a little bit they react with water, right? So we move on. We were able to see some of them that do not react with water at all, like magnesium, zinc, iron, lead, copper, silver. They do not react with cold water at room temperature. Now we're going to be moving on to the next set of metals, which react with steam. All right, they react with steam. And steam means what? They react with hot. They react with boiling water, or right, not in a normal condition. So we have so metals metals below magnesium, like zinc, iron, and onwards, react with steam, right? They do not react with water, not with water, but they react with steam, but not with water. Water means some water at room temperature, right? They do not react with water at room temperature. So, so how does the experiment generally takes place? So metal plus steam gives metal oxide plus hydrogen gas. Yes, all right. So the metal is strongly heated until it becomes, so how the procedure that is taken is metal is strongly heated. All right. The metal is strongly heated until it becomes very hot. Until it becomes very hot. All right. And then and then until it becomes very hot and placed over steam. We'll write about the metal is strongly heated until it becomes very hot and reacted with steam, or is introduced to steam. All right. Then, or you can say the steam is passed over, or steam is passed over a very hot metal. All of these things can be done. Once that is done, the metal reacts with water, the steam, and produces metal oxide and the hydrogen gas. Now, if you look at all of these reactions generally, if you look at all of these reactions, you're going to see that basically, if you look at the previous reaction, you will see basically the reactive metals, the metals that are at the top of the reactivity series are just basically displacing hydrogen. Can you see this? If you look at sodium, when it reacts with water, basically it is forming NaOH, right? Uh, right? And hydrogen gas. So this hydrogen gas basically is doing what? This sodium is actually
Sir,
replacing
what's the
hydrogen.
sixth word in line 2?
I want you to understand this first, Eileen, then you can write later words. I want you to see the more reactive metals, the metals that are in higher in reactivity series, basically they replace, they displace hydrogen as a gas, right? They're displacing hydrogen as a gas. This is also actually also a reduction reaction. It's a reduction reaction. Reduction of hydrogen is taking place, right? Reduction of hydrogen is actually taking place here. Give me a second. If you
Sir,
look at
can we call this a displacement reaction?
this is you cannot call this a displacement reaction at the moment, because this we when we refer to displacement reaction means one metal is displacing another metal. Here sodium is the hydrogen that is being produced over here is not a metal, right? So we are not going to call this as a displacement reaction, but we will call this as a reduction of hydrogen gas, right? This is reduction of hydrogen gas. Why? If you look at the oxidation state of any solid in its natural state, when it is not making any compound, is actually zero. But hydrogen here is making a compound with oxygen. So oxygen is 2 negative in charge and hydrogen is 1 positive. But there are 2 atoms of hydrogen. That is why the oxidation state of hydrogen is going to be 2 positive here, and the oxidation state of oxygen is 2 negative. Here, sodium is making a compound, right? It has 1 plus charge, and oxide ion has 1 negative charge. So the oxidation state of sodium over here is 1 plus, and oxidation state of this anion of a hydroxide ion is 1 negative. You see, oxygen from zero, sodium from zero has become 1 plus, right? Can you see this? Sodium.
Yes.
So there is an increase in the oxidation state. From zero, it has 1 plus. So this is going to be called oxidation, right? This is oxidation.
Yes.
And if you look at hydrogen, what has taken place? Hydrogen from 2 plus, its oxidation state has become zero, because any element in its natural state has and if it is not making a bond, it has zero oxidation state. So this is the reduction that has taken place of hydrogen. So that is why we call these reactions reduction of hydrogen. Do you understand? Reduction.
Yes.
So overall, this reaction is redox reaction. I want you to understand something over here very important. We are so whenever a strong, all of these elements, all of these metals are above hydrogen. That is why they are able to react. All right. Some of them, the ones that are closer to hydrogen in the reactivity series, if you could recall the reactivity series, reactivity series was potassium, sodium, calcium, magnesium, aluminium, zinc, iron, and between iron and lead there was hydrogen over here. Hydrogen, right? There was hydrogen over here. I have written it outside because this is not a metal, but still it comes in the reactivity series. Then we have copper, then we have silver, and then we have gold. So all of these elements, the top ones, they are very reactive. They actually displace, or they remove, or they immediately reduce the hydrogen into hydrogen gas in water, right? But these are bit lesser reactive, right? Why? Because they are getting closer to hydrogen. Do you understand? They are getting closer to hydrogen, so their reactivity with hydrogen is kind of reducing. The difference between their reactivity is reducing. You understand? They are very reactive. Their reactivity is way more than, they're very reactive than hydrogen. That is why they do not, at room temperature they are able to reduce. At room temperature they are able to remove water, right? Their reaction with water, which is cold, right, at room temperature, takes place. But for the other ones, like these, they need to be either hot or heated very strongly in order to react with water. To react with water. Why? And give hydrogen gas. Why? Because they are getting closer to hydrogen, so their reactivity is, they are not very reactive than the hydrogen, so there needs to be extra energy that has to be given into the reaction so that it reacts and removes hydrogen. Do you understand? So that it reacts with water. Is this clear, Alijba?
Yes, it is.
Very good. So now we proceed. So there was something, this was something that I wanted you to keep in mind, inshallah. Even though we have already, I think we did discuss that when we were doing the previous lectures, but it's okay. So the procedure, so this is the procedure. So what takes place now if you react magnesium magnesium needs to be hot condition and reaction. So what? Magnesium needs to be hot. Magnesium needs to be hot. And what is the reaction? Reacts violently. Reacts violently with steam. If you could recall our previous lectures, it barely reacted with water. The reaction with water was very slow, almost like none, if you could recall, right? So but it reacts violently because it is hot. With steam it reacts violently. All right.
Yes.
So what is white MgO? White magnesium oxide is produced. White magnesium oxide powder is produced in reaction. And the third point is, the third observation, that is a, a bright white glow. A bright white glow is seen, observed in the reaction. What is the equation? Equation of the reaction. They need to be memorized. You need to be memorizing all of them, inshallah. Okay. Water. You see now it has changed. It has changed. Before it was liquid. Now it has changed into gas. Do you see? Before it was reacting with water. So it was at room temperature, which water is room liquid at room temperature, right? Yes. This is the equation that you have to keep in mind. All right. Are you writing this with me as well?
Yes.
Yes.
All right. All right. Let me know when you've done.
सर आप सऊदी आ गए?
Not yet. Not yet.
Okay.
All right. So sodium, right? Sorry, magnesium. After magnesium is zinc. Zinc. Zinc needs to be hot. Hot zinc, right? So we have been able to understand that these metals which are below calcium, magnesium, zinc, they were not able to react with normal water temperature, water at normal temperature, right? So we need to put some extra energy into them. So by making them very hot and by reacting them with steam, that is when they were able to react with water. In normal, general, simple circumstances, they don't. You understand? Or the magnesium reacts very slowly. Zinc does not react with water at all at room temperature. So there was some extra that had to be done with them. So now they react with so all of them are being kept hot at the same temperature. So the zinc reacts readily to give zinc oxide and hydrogen gas. Zinc oxide is yellow. Zinc oxide is yellow. Okay, yellow when hot and white when cold. Important information, okay? But we do not see any flames or anything like that. So what is the reaction? Zinc, zinc solid with water. Here, is it water? No, this is steam, gas. This is important to see. They can ask you by making an equation like this: zinc plus water, and they put a liquid over here and they say, is this a correct equation? No, this is not a correct equation. Why? Zinc does not react with liquid water, with water in its liquid form at room temperature. This liquid means room temperature, right? It does not. So this equation is wrong. You have to make sure that you are able to see the states properly, right? States properly to form zinc oxide and hydrogen gas. All of this is memorization. You have to memorize, obviously. Then we have iron, which needs to be red hot, or you can say very hot. Very hot. You see now, they both of the zinc and magnesium reacted with steam when they were hot. But iron, if it was only hot, it would not have reacted with steam. You understand? It would have not reacted with steam at hot, but needs to be very hot or red hot. You understand this point? Now, so definitely this is an indication. This is telling us that if a zinc iron is less reactive than zinc now, right? So red hot iron reacts slowly with steam. Even if it is kept red hot, it still reacts slowly with steam to give iron oxide and hydrogen gas. And iron must be heated continuously to react. If it is not being heated continuously, it will not react. What is the reaction? 3Fe plus gas plus Fe3O4 solid plus 4 gas. Is this clear? And then
Yes.
and the last one, Pb, copper, Ag and Au. All of them don't react with steam, even if red hot. Even if they are kept very hot, constantly heated, they still do not react with steam. And the amazing part is that all of them are below hydrogen actually. Right? They are below hydrogen. So they are less reactive than hydrogen. So there's no chance that they can ever displace hydrogen from water. They can ever reduce hydrogen, right? So they cannot reduce hydrogen to hydrogen gas, right? What is reduction? Abhi, I want you to stop writing and listen to me. What is reduction? Reduction to gain electron, right? So if they are less reactive, I've told you what is the metallic property, Alijba. What is the metallic property? Metallic property is to give electron, right? If lead
To gain, give
give
electron.
electron, if copper, silver, and gold are less reactive, it means then hydrogen or iron, it means iron is going to give electron first rather than lead, copper, and silver, right? Hydrogen can lose electron much faster than lead, copper, and silver, right? They can lose electron much faster. We will study this thing in when we go into discussing displacement reaction. If two metals or two metals are present in a solution, one of them is more reactive, what does it do? It forcefully gives its electron to the metal. Are you getting my point?
Yes.
Two metals are present in a solution, the more reactive metal is going to give its electron to the lesser reactive metal. This is called displacement reaction. We will study ahead, inshallah. So this is what hydrogen does. Basically, these poor guys, they lead copper, silver, and gold, they do not have enough power to give electron to hydrogen and to convert that into a hydrogen gas, right? What we have studied up till now is, this is what we were studying, right? 0, 2 plus, 2 negative, sodium 1 negative, 1 plus, and hydrogen gas. This is what we were studying, right? So sodium actually forcefully gave hydrogen an electron to convert it into hydrogen gas, right? This is what took place, right? Hydrogen was 2 plus. Here it is 0. It means this means hydrogen would have gained 2 electrons. That is the reason it has become something like this, right? It would have gained 2 electrons, right? Where did he get these 2 electrons? If you balance the equation out and if you balance everything out, you will see that basically it was sodium that gave him those 2 electrons. Do you understand?
Yes.
So sodium forcefully gave 2 electrons to hydrogen so that he can go off, and he made a bond with hydroxide ion. Do you understand this point?
Yes.
Sir.
So this is how things work. So, but lead and copper and silver and gold are not strong enough to give hydrogen. They are not more reactive. Reactivity of metal is what? Giving electrons, right? Making other people gain electron. So a stronger one can make a weaker one gain electron. They were weak enough. They are weak enough to be able to make hydrogen gain electron. You understand this point? So in conclusion, you can write.
Yes.
So when we talk about this, you can say that they are weak enough. Why do they do not react with water? We'll see that they do not even react with acids. We'll see why. They are weaker reducing agents than hydrogen, or they are less reactive than hydrogen and are not able to give electron to hydrogen. You understand? So they are not going to react with steam as well. They were not, if they were not reacting with steam, how could they have reacted with water? So they do not react with steam, and we'll see that they do not even react with acids. You'll see that they do not even react with acids. I want you to write this down.
Gcse.
All right, let's move on to important conclusion from this then. What we have concluded by their reaction with water and steam up till now is that the experiments that we have done with steam results from steam and water experiments. All right. Let's inshallah let's join for the next session. Then we will do that inshallah. Okay.